Hello and welcome to the discourse. Logic is one of the most important tools of science. Science is not solely empirical. You cannot simply collect and analyze data if you want to predict and explain the workings of the universe. Every person on the planet can predict that the sun will rise tomorrow in the east. Okay, it does not rise, but set that aside for the moment. They have a lifetime of empirical data that lets them make that prediction. But few can explain why the sun is rising in the east every day. That requires explanation, a theory. And an explanation can never ever be found in the data. An explanation in the form of a theory is a free creation of the mind that must be logically consistent with related theories. The theory itself is assessed in a variety of ways, one of which includes the internal logical consistency. The theory should generate hypotheses that are logically derived from the theory's axioms and propositions. The theory should be testable, that is, the hypothesis must be amenable to empirical testing. A logical argument is needed to assess the quality and effectiveness of the testing processes, that is, the methodology. The variables that are deemed to be empirical manifestations of the concepts central to the theory must be logically defensible. In short, logic is central to every phase of the scientific process. Throughout history, there have been two main ways humanity has attempted to gain knowledge about the world. Top-down, where we start with certain principles and demand logical self-consistency, and bottom-up, where we obtain empirical information about the universe and then synthesize it together into a larger self-consistent framework. The top-down approach is often credited to Plato and is known as a priori reasoning, with everything being derivable as long as you have an accurate set of postulates. The bottom-up approach, contrarwise, is attributed to Plato's successor and great rival Aristotle and is known as a posteriori reasoning, starting from known facts and building up your model of reality from that foundation, rather than deriving them from overarching postulates. In science, these two approaches go hand in hand. Measurements, observations, and experimental outcomes help us build a larger theoretical framework to explain what occurs in the universe. While our theoretical understanding enables us to make new predictions, even about physical situations we have not encountered before. However, no amount of sound logical reasoning can ever be substituted for empirical knowledge. Sir Francis Bacon is known as the father of empiricism. Time and time again, science has demonstrated that nature often defies logic, as its rules are more arcane than we would ever intuit without performing the critical experiments ourselves. One such instance was when logic was used against the evolving science of evolution. William Thomson, the first Baron Kelvin, was born on 26 June 1824. He gained fame as one of the greatest British mathematician, mathematical physicist and engineer of England. He was the professor of natural philosophy at the University of Glasgow for 53 years, where he undertook significant research and mathematical analysis of electricity, the formulation of the first and second laws of thermodynamics, and contributed significantly to unifying physics. During the same time, Sir Charles Darwin was also postulating his theory of evolution. Darwin was born at the best of times in 1809 when conditions were highly conducive for his theory to flourish, but he died in 1882 at the worst of times because there was a real danger that it might soon be killed off. Darwin's nemesis was the eminent physicist Lord Kelvin, and the weapon used against him was the age of the earth. By the mid-1800s, Charles Darwin was well into the process of revolutionizing how we conceive of not only life on earth, but of the age of earth as well. Based on the current rates of processes like erosion, uplift and weathering, it was clear that the earth needed to be hundreds of millions, if not billions of years old to explain the geological features that we were encountering. For instance, Darwin calculated that the weathering of the Weald, a two-sided chalk deposit in southern England, required at least 300 million years to create for the weathering processes alone. This was brilliant on the one hand, because a very old Earth would provide our planet with a long enough time frame so that life could have evolved to its present diversity under Darwin's rules. Evolution through random mutations and natural selection. But the physicist William Thomson, who would later become known as Lord Kelvin, recognized this long duration to be absurd. If it were true, after all, the Earth would have to be much older than the Sun, and therefore the long geological and biological ages that Darwin required for the Earth must be incorrect. Many scientists of that time were religious and believed in theistic evolution that said that a supernatural agency was guiding the process to produce the desired ends. While all models of evolution required long times, natural selection required much longer times than any guided selection process. Hence, the younger the age of the Earth, the more likely it was that natural selection could not be the mechanism. Physicists led by eminent Kelvin himself, a theistic evolutionist, were leaders of the charge for a young Earth. Though it must be emphasized that young at that time meant around 100 million years or less. Even religious scientists had abandoned the idea of the Earth being just 6,000 years old. Beginning around 1860, Kelvin and other physicists started estimating the ages of the Earth and Sun using the nebular hypothesis proposed around 1750 by Immanuel Kant and Pierre-Simon Laplace. This model treated the Earth and the Sun as starting as rotating clouds of particles that coalesced under gravity to form molten balls, with the Earth subsequently solidifying and cooling. Kelvin used the laws of thermodynamics and other physics principles to arrive at estimates of 20 to 400 million years. By 1879, the upper limit had been lowered to about 100 million years for the Earth and an even shorter upper limit of 20 million years for the Sun, much less than the 200 million years or so believed to be required for natural selection to work. Since physics was considered to be the most rigorous of the sciences, things looked bad for natural selection. For decades, biologists and geologists had no answer to Kelvin's arguments. As it turned out, though their estimates for the ages of the Earth, both from perspective of the time scales required for geological processes and the time necessary for evolution to give us diversity of life we observe today, were not only correct but conservative. What Kelvin didn't know was that nuclear fusion powered the Sun, a process entirely unknown during Kelvin's time. There are stars that get their energy from gravitational contraction, but those are white dwarfs, which are thousands of times less luminous than Sun-like stars and shine for longer than any Sun-like star can under the power of nuclear fusion. Even though Kelvin's reasoning was sound and logical, his assumptions about what powered the stars and hence his conclusions about how long they lived were flawed. It was only by uncovering the physical process that underpinned these luminous heavenly orbs that the mystery was solved. Yet that premature conclusion, which rejected the geological and biological evidence on the grounds of absurdity, plagued the scientific discourse for decades, arguably holding back a generation of progress. This is an example of how absurdism appears logical in absence of complete knowledge. However, knowledge is immense and immeasurable. Only a small percentage of our known universe is visible and hence knowable. Around 25% is dark matter, of which we know nothing, and around 70% is dark energy, which continues to remain in dark. As we will continue to expand our horizon of knowledge, we will continue to reject many such ideas that may appear logical right now but will appear absurd in future. So this is it for today. We will continue to discuss science, space and technology in the upcoming days. Please stay connected with the discourse. Thanks and regards.